Hello, good evening. I welcome you all on this online learning platform of Shikuya. Today, we will see one more coding problem statement. So, you have this statement in front of you. Bob is working on his exercising skills. He found an exercise where he will be given n stacks in front of him with their position marked as 1, 2, 3. This number goes up to 9 with height of the stack in position I given by hi. Here it should be small I. Okay. Bob will start by standing on a stack at position k, and he will jump on the stack placed I, the right of the current stack. Basically, he can jump only on the stacks with k, k plus 1, k plus 2 up to n. But there is a twist. To make this exercise more difficult, from any stack, he can only jump onto a stack having height strictly greater than the current stack. You need to find out the consecutive number of stacks he can stand on, including the initial stack at position k. So first of all, you need to understand the scene. So Bob is exercising, okay, and there are stacks. Now I tell you what is the meaning of this. That means consider that these are the stacks. So this is the first stack, this is the second stack, then the third one, and suppose this is the fourth one, and this one is there, and one more will be there. Okay, so these are the stacks, and say this is number one stack, this is stack number 2, stack number 3, 4, 5, 6, so it goes on up to n. And here Bob is standing on a particular stack position. Okay, first of all, you need to understand the positions are marked as 1, 2, 3. This goes up to n. Okay, and it is with height of the stack in position given by I. That means suppose this is the height of, this is height high, and this is given by h of I. Okay, so we need one array to store the height of particular position, and this is the value of I. So what is the height of this will be represented by h0. Okay, the value stored at array having index 0 will be the height of the first stack, and h1 will represent the number stored in the index 1 of a array will give you the height of number 2. Okay, so this is the scene. Then Bob will start by standing on a stack position k. So suppose Bob is standing over here. Consider that this is Bob, and where he is starting, it is position k, and the scene is that the Bob is jumping. So from this stack, Bob can jump at the stack number 4. Okay, this goes on, but if you read it carefully, there is one condition. He can jump only on the stacks, okay, which are at the right of the current stack. So Bob can jump from stack number 3 to 4, from 4 to 5, from 5 to 6. That is the stack which is at the rightmost side. On that stack only Bob can jump. But there is a twist. To make that exercise more difficult, okay, from any stack he can only jump onto the stack having height strictly greater than the current stack. That means suppose Job is at stack number 3. He jumped from stack number 3 to stack number 4. Now, if you check over here, it is stack number 5, which is smaller in height than stack number 4. So he cannot jump from stack number 4 to stack number 5. Why? Because the condition is Bob can only jump from one stack to the another if the next stack is having the height than that of the current stack. That means suppose the Bob is standing here on the stack number 1. He can jump to the rightmost stack, that is stack number 2, because stack number 2 is having the greater height than stack number 1. Then from stack number 2, he will jump to stack number 3, because stack 3 is having more height than stack number 2. This goes on. This goes up to stack 4, but the stack 5 is smaller in height compared to stack number 4. Therefore, he cannot jump. Okay, this is the scenario. And what is asked, you need to find out the consecutive number of stacks he can stand on, including the initial stack at position K. The situation is, suppose I redraw it over here. Suppose this is stack number 1, stack number 2, stack number 3, stack number 4, and this is the smaller one, stack number 5. Suppose Bob is at stack number 4. He is standing on stack number 4. So can he jump from stack number, this is stack number 4, this is stack number 5. Can Bob jump from stack number 4 to 5? No. Why? Because the height of stack number 5 is smaller than that of stack number 4. Therefore, Bob cannot jump from stack number 4 to 5. What is the current position of Bob? The starting position of Bob is 4. Therefore, how many stacks Bob can jump, including the current stack? This is the scenario. Find out the consecutive number of stacks he can stand on, including the initial stack at position K. So in this case, if the current position of the Bob, the starting position of Bob is number 4, then he cannot jump to number 5. Therefore, the output is 1. That means how many stacks Bob had jumped, including the current stack. He cannot jump to any other stack, and the current stack is 1. So including current stack, the output is 1. In the example, the input is given. What should be the input? Suppose the first input is 5, which represents number of stacks. So in a program, first of all, we need to give the input. That input will represent number of stacks. Then in an array, we will store height of individual stack. So 85, 26, 91, 72, and 50. These are the individual stack heights. And then K, that is the initial position, okay, of Bob. And when these are the 3 inputs that we need to give to the program, and the output is 1. Okay, so just I erase this, and we will try to understand what this example 1 is telling us. Suppose we have entered 5. What is the meaning of 5? Number of stacks. So consider these, there are 5 stacks. The height of first stack is 85. So I write here 85. The height of next stack is 26. So write here 26. Then 91. So I write here 91. 72. So it is 72. And then 50. So this number represents 50. And there are 5 stacks, and these are the heights of every stack. And the initial position of Bob is stack number 4. So this is stack number 1, stack number 2, stack number 3, and stack number 4. So Bob is standing on stack number 4. This is his initial position. Now, can he jump? The condition is Bob can jump at his rightmost stack. So he can jump at stack number 5. But the second condition is he should not jump onto a stack whose height is smaller than the current stack. Now Bob is standing on a stack having height 72, so he cannot jump on a stack which is to his right side, which is having the height 50. So how many stacks Bob can jump including his current stack? So he cannot jump to the next stack, therefore the output is 1. 1 is nothing but his current stack position, okay, including that. In example 2, so I raise this. In example 2, inputs we have given input as 4. That means there will be 4 stacks. So the height of first stack is 76, the next stack is 1, then third stack height is 22, and then 81. Okay, these are the heights. Then 2, that is Bob is standing on stack number 2. So here Bob is standing, and when he's jump to his rightmost stack, he will jump on stack number 3 because its height is greater than his current stack. He will jump from stack number 3 to stack number 4 because 81 is greater than 22. Okay, so and after 81 the stack ends. Therefore, how many stacks Bob has jumped including his current position? So he started from stack number 2 and he jumped up to 4. So 1, 2, and 3. Therefore, the output is 3. So this is the scenario, and we need to write a code for this. So for that, I directly take you to the compiler. So here, today we will write a code using C++ programming. So first of all, I need to include the header file. So I write #include, and within angle brackets, I'll write iostream. Okay, then we need to use a namespace. So I write using namespace std. We will use a namespace std in which the declaration of scene and cout objects are pre-declared. Then I start by writing the main function, that is in the return type of main function is integer, and then as it is the main as it is the main function and its return type is int, therefore I write here return 0. Okay, then the program starts. Here we need how many variables? So if you see over here, we require total 2 variables. Okay, first variable gives us the number of stacks, and the second variable gives us the initial position. Okay, so I write here I will declare a variable n for number of stacks and position, which represents the initial position or the current position of Bob where he is standing. Then we will prompt the user. So I'm using cout, and we will say enter number of stacks, then and the current position. So this is what we have prompted, and whatever user will enter, we need to store it into variable n and position. So I write here n with extraction operator. I write here position. So user will enter 2 integers. The first integer will be stored in variable n, and second will be stored in variable pose. N will represent the number of stacks, pose will represent the current position. Then if you check here, we require an array, okay, to store the height of individual stack. So for that we need to we need to create one array. So I write here integer type array, and n represents the number, okay, which we have taken from the user. So for example, in this example number 1, first input is 5, which represents number of stacks, okay, and therefore the array, the size of the array is 5. So here we have written n, that means the size of an array. Then we prompt the user to enter stack heights. So I write enter stack heights. So user will enter heights, and now we need to store them into an array. For that we will use a for loop. So we need one variable. So I take here I as a variable inside this for loop, and the value of I goes up to n and the updation part is there. So I write here I plus plus, and within this for loop I will write cin with extraction operator. I write here array and I. So suppose user enters the value of n is 5, then the value of I goes from 0 up to 4, because the condition is I is smaller than n, okay. So total elements stored in an array will be 5, okay. Next, the next thing is what we need here. We need to find out the output, that means how many stacks Bob will jump. For that we will declare one variable which is integer variable. So I write here int, and I give the name to it as count, and I initialize it with 1. Why? Because when we measure the number of stacks Bob had jumped, we will include the position, the current position of his stack. Therefore, including the current stack, that means we should start with 1. So count is equal to 1. Then again we need a for loop. So I just copy this part here, okay, and I will paste it over here. So here again in this for loop, I initialize the value of this I as position minus 1. Why? Because here you can see that in day-to-day life we start counting from number 1, but in an array, if you consider an array, suppose this is an array, the indexing of array starts with number 0, okay. So here whatever is the current position of the user, we need to take its previous number, that is position minus 1. That means I will show you. Suppose Bob is standing here at stack number 4, okay, at stack number 4, but in an array it is actually 0 1 2 3. He is standing at index 3, okay. Are you getting me? Therefore I have written here position minus 1, and then the value of I should go up to n minus 1. Why n minus 1? Because we are comparing here. We need to compare there whether the next stack is greater than, the height of the next stack is greater than the current stack. For example, I will give you the same example as it is given in example number 1. So 85, 26, 91, 72 and 50, these are the stack heights, Okay, so we will check. Suppose Bob is standing on the height of stack which is 26. Now we need to check whether the next stack, that is the third stack, the height of the third stack is greater than the current stack. If it is true, if the height of the third stack is true, then only he can jump on the third stack, else he will not jump. Okay, so to check that condition, what we have done here, we start from, if we check, we start from its current position. Okay, -1, that means we are now considering the index because we are dealing with an array. Now we go up to n-1. Why n-1? Because suppose this is the last stack, this is the last stack, and suppose this is 93, consider this as a 93. So when Bob jumps from 26 stack to 91 height stack, then he jumps to 93 stack. Now this is the last stack over which he can jump. So when the current position of Bob is at the second last stack, then he just checks whether this stack is greater in height from the current stack or not. Okay, but when Bob will jump over here, he cannot check the height of the next stack because there is anything after this last stack. So we need to take the second last stack for comparison purpose, and therefore I have written here n-1. What is n? N is the number of the last stack. Okay, then inside this for loop we need to check a condition. So I write if, then we will write array I is smaller than ARR I plus 1. Okay, this is the current array index, this is the next array index, and then if it is true, then we have a count which we have initialized with the value 1. We just increment it. Okay, else, that means if the height of the next stack is smaller than the current stack, then else we will break and we will stop. So now in count variable we have the number of stacks Bob had jumped, so we just need to print out it. So using cout, I just print the value of count variable. So this is our code. Okay, so I will compile and run it. It is compiling. Yes, now it is asking me to enter the number of stack and current position. I will take the same example. Okay, so I will take the same example 5 and this array. So I take it, I enter 5, and then the current position is 4. Enter stack heights. So we will enter stack height as 85, 26, 91, 85, 26, 91, and 72 and 50. 72 and 50. Here we are getting the output as 1. So here we are getting the output as 1. Now I will one more time, I will execute the code. So if I compile and run it again, so it is asking me to enter the number of stacks and current position. Now suppose there are total 4 stacks and the current position is 1. That means Bob is standing at stack number 4. and the heights, now we will give the heights in ascending order. Okay, just to check it. So I write 10, then 15, then say 35, then 41, and last one is say 49. So if I enter, it is giving me 4 because he is there. Then 1, 2, 3, 4. Okay, so this is the code. You can write and implement your code in Java or Python. So today we will stop over here. In the next session, I will come with a different coding problem statement. Thank you very much for attending the lecture. We will stop here today.